So for our next exercise, we could grab a few elements from the previous code, but I'm going to open directly the code that is also available in the website and that has already the elements that we want to work with. And we can work either in the previous Rhino file that has all the information of the AutoCAD file, or we can work in the new one. In this case, I'm going to work in the new one just to show you how I don't need the Rhino file to work with the elements from the previous code. So I'm going to open Grasshopper. And I'm going to open, as I said, the code that it's available in the website with the parameters we are working with. So I'm going to do File, Open Document, and you'll see that the base code for this exercise already has the elements from the other code. So we have our counter lines, we have our preliminary terrain, the 3D limits of the terrain, and that 2D square. We won't be needing all of this, but we'll have them here in case we needed them for any step. And we can always copy now these elements to any new code that we want. What you'll see is that I'll open a new Rhino file and I have the elements here, but if I select them, they are not appearing in Rhino. If you remember from the previous exercise, these elements were georeferenced, so they won't appear at the origin point, but I can zoom in on them. In this case, I'm going to do the same as I did in the other exercise, but in Grasshopper. If I select, for example, my preliminary terrain, and I come to View, Zoom, I can do Zoom on Preview, and it will zoom in on the geometry that I have selected. So I'll click Zoom on Preview, and you can see it zoomed in Rhino on that geometry that I selected. So now I can see what I am doing in Grasshopper within Rhino. So for this exercise, as I said in the end of the previous one, we had this preliminary terrain with a lot of strange triangulations in some places. So the objective for this exercise is to smooth out the surface for our terrain. And how we will do that in this exercise? We will do it by constructing a series of profiles of our terrain in the X and Y directions every 2 meters or 5 meters. That not only will give us sections of our terrain that we can already work with, but that in the end will give us a uniform matrix of points that will be in their respective heights, but then we'll create in the empty spaces a few more points for us to work with. And then from this new matrix of points, we are going to rebuild our terrain, and as it is more uniform, it will create a more smooth surface for our terrain. And so we will have to build these profiles of the terrain. For that, we will need some informations from the terrain. So if we have our terrain like so, to do our profiles, we're going to need the direction from which they are going to be made. So we are going to say it's going to be from here in that direction and from here in that direction, for example. And to do that, we'll need this base point to tell us from which the profiles are going to be constructed. And to that, what we are going to do is to build the box where the terrain is included, the volume where the terrain is included, we are going to select these two faces of the box to then take the center point of those faces to serve as a point for the direction of the profiles. You'll see as we are doing the code. But so, to construct this box where the terrain is included, we are going to do an operation which is called bounding box. If we connect to our preliminary terrain, you'll see that it will build the box, the volume where the terrain is included. So now, as I was telling you, we are going to want to select two, in this case, perpendicular faces, because we'll want two perpendicular directions for our profiles. So what we'll need to do first is to deconstruct our box into its several elements. So we'll do deconstruct creep, as we want to deconstruct the surface. In this case, we will connect our box to this deconstruct creep. And it will deconstruct into three outputs, which are the faces, the edges, and the vertices. And so now, as we want the faces, we are going to select those two faces. To select elements within a group in Grasshopper, what we do is an operation called list item. And this list item allows us precisely to select surfaces, giving it a specific index. What you'll see is that from these faces, I'll have, for example, this face, which will be the face with index 0. Then the next face will be the face with index 1. The one from the back is going to be index 2. And this one will be index 3. And then the top and bottom ones would be probably index 4 and index 5. Obviously, this could be dependent on how the program is reading your surface, and these indexes could be different ones. Okay, but so in this case, we want to just select two perpendicular ones, so we can, for example, select the one with index 0, which is the default one here, and the one with index 1. So if I now connect my output F for the faces into my list item, you'll see that it will select by default the one with index 0, which is this one, as I showed you. If I wanted now to select the one with the next index, with index 1, if I zoom in into my list item component, you'll see that a plus sign will appear at the top and the bottom. So if I select here plus, it will give me the next index, which in this case, it's that face. If I wanted, I could connect a specific index to this input. If I, for example, wanted to connect, I wanted to select the face with index 5, I could connect the number 5 here to this input, and then it would give me that face with that index. But in this case, as we will just want these two perpendicular ones, and select index 0 and plus 1. And so we have selected these faces. And so now, as I showed you, I'm going to need the center point for these faces in order to give the direction of each profile. And I'll do that with an area component. And why an area component? Because this area component, besides the value for the area of any given object, will also give me the center of that given object. So if I connect each of my faces to an area component, you'll see that it will give me the center of those faces. So now I already have the center point for my profiles to be drawn. So now we'll do precisely that, our profiles. And we'll do our profiles with a specific command called counter. So it will do the counters from the surface that we tell him to do. And so the inputs that the counter will ask us, I'll do that too for both directions. The inputs will be the shape, so the surface for which we're going to do the counters, the base point, which is these points that we just gathered, the direction, so it will be X and Y, and the distance between the counters. And so the shape will be obviously our preliminary terrain from the beginning. So I'm just going to connect the preliminary terrain to both my counters. If I want to, this is just a tip for the organization of our code. If I don't want these connections to be above the rest of the components, if I double click a connection, it will create this relay. And this relay just serves for me to reorganize the code, as you can, the connection, as you can see here. And I can even, if I right click it, write something on my relay to say what I'm doing with that connection. So for example, I could write connect to the preliminary terrain, like so. And not only don't I have the connection above the rest, I now have specific thing, specific operation. Okay. This is just a quick tip for organizing our codes. So now I have fed to my counters the shape to which I want to do the counters. The next step will be the base points. So we'll grab the center points from our areas components and feed them to the P input. So the next thing will be the direction. As we know, one of them will be in the X direction, the other will be in the Y direction. So if I write X unit, it will give me unit X. And so I can just connect it to N, and I have the direction for one of the counters. And then for the other, I can write Y, and it will give me unit Y, and just connect it to this direction. So again, one will be in the X direction, the other will be in the Y direction. So then we can cross both profiles and create the new matrix of points. And now the distance between the counters will define for now as 2. All right, 2.0. So now I'll connect this distance to both of them so that they have the same value, and it will do the profiles for our preliminary terrain. You can see here, if I zoom in, it has created a series of profiles in one direction and a series of profiles in the other direction. So now I'm just going to store these profiles, in this case, in the curve parameter, as they are linear elements. But for now, I'm not going to internalize the data in these parameters because later on we are going to change the distance between the profiles. But I can change the names for these parameters, for example, profiles X, profiles Y. And if I want, I can bake them into Rhino to have the sections of our terrain. So what I'll do is create a layer in Rhino for each of the profiles. So I'll minimize Grasshopper, and in my Rhino file, I'll create a new layer. I'll call it profiles X, a new layer, profiles Y. And I can already create a layer for our final 3D terrain. Okay, but so I've created a layer for each of the profiles, and now I can come here to the profiles X, right click it and do bake into the layer profiles X, and do this now the same for profiles Y, bake into the layer profiles Y. And so now, if I deselect everything that I have in Grasshopper and come into Rhino, I have all my profiles in their respective layers and individually. So if I want, I can select an individual curve, and then if I wanted, I could export it to AutoCAD if I wanted. So now I have sections of my terrain with which I can work. So now I'll come back into Grasshopper. And now what we'll want to do is to construct our new terrain by crossing these two new sets of profiles. In order to do that, first we'll need to do something. If you remember from the last exercise, we can reorganize items, groups of items in Grasshopper by doing two specific operations, which are called graph tree and flatten tree. If you remember, graph tree allows us to put each element into each individual drawer, and the flatten tree will put all the elements in a group of items in one drawer. And we'll want to do these two operations for these profiles because when crossing, what you would see is if we had, for example, something like this. If we were to cross these two sets of elements like they are now, it would cross the number one of one set with the number one of the other set, and then the number two with the number two, and so on and so forth. And so the final result would be this. And this does not interest us. We want to cross all of the elements with all of the elements. So what we'll want to do is to put one set of profiles individualized and the other set of profiles as a whole. And so when we then cross, if we have all of these profiles organized in one single drawer, and then all of these individualized, what it will do is cross the number one of this set of profiles with all of these, then number two with all of these, number three, and so on and so forth. And so when crossing number one with all of these, it will give us all of these. Then number two with all of these will give us all of these points, and so on and so forth. And so in this way, we'll have all the connections that we want. And so what we'll do is do a graphed tree for one set of profiles and a flattened tree to the other set of profiles. It doesn't matter which one, just that one is individualized and the others are as a whole. So now if I were to put a panel here just to show you how they are organized, these should all be in their own individual drawers, and these should all be in just one drawer. And that's exactly what we want. So now I'm going to cross both profiles with an operation which is called curve/curve. You can write CCX for it to appear or come here. And so this will intersect both sets of profiles, and it will give us the points between. But before doing the operation, as I told you before, we are going to change the value here for the distance between the profiles to 5, because what I've gathered is that every 2 meters, it might take too much on the computer, and it might not even be able to process the intersection. But for the objective of the exercise, I think if we change the value here to 5, it will do the same. So I changed the distance for the profiles for every 5 meters. You'll see that it won't be the same as the profiles that we baked into Rhino, but that's okay. So now we have profiles every 5 meters, and so now I'll do the operation. And so it won't be too heavy for the computer to process. You'll see that in the end, after processing, it will give us the points of intersection between the profiles. And so now we have basically our new matrix of points in order to do our new terrain more smoothed out. But there are still a few things that we have to do. First thing, just going to turn off here the layers in Rhino. If I show you with the 3D limits of our terrain, you'll see that if, for example, in some limits we might have the cross points, as we have in this limit here. For example, in other limits, we don't have those points. So one thing that we'll do is, as in the previous exercise, we'll grab these 3D limits and we'll divide the length of those limits as we did for these profiles, every 5 meters. And so we'll make sure that we have points in the 3D limits of the terrain to do our new surface. And then we'll merge them and we'll do, as in the previous exercise, remove any duplicate points that might exist in our new point cloud. So I'll grab the 3D limits that I had in the beginning of my code. I'll take it here further on. And so the first thing that I'll do is isolate each of the 3D limits. So I'm going to do a graph tree. And then I'm going to do a divide length. I will divide them according to the same distance that I divided my profiles. So I'm grabbing this value here, and I'm going to connect it here also. So in this way, I'll make sure that the profiles and the 3D limits are divided by the same value. So now I've divided each of my terrain limits with the same number of points, more or less. So now I can merge my two new sets of points in order to do our final terrain. Make sure that they're all in the same drawer. To make the terrain, I'm going to do a flattened tree. And so now you can save your code before this, but I will do, as in the previous exercise, a cull duplicates in order to remove those duplicate points that might exist. So I'll just connect to my flattened tree. It will process my cloud point, look for any duplicate points, and remove them. Has removed any duplicate points, so the only thing we're left with is to do our final terrain. So, as in the previous exercise, we do the operation Delaunay mesh, which will triangulate the points. And you'll see that will have a more smoothed out surface than the one that we had before. So before, you see, you still had a messy triangulation in some spots, and now with the newer one, you have a more smoothed out surface. Again, if you wanted to try, you could change this value between the profiles to 2, to 1. The less distance between the profiles, the more detail you will have and the more smoothed out the terrain will be. But I think for the purpose of this exercise, this will do just fine. So now I'm just going to store the terrain in a mesh parameter. Call it final 3D terrain. And now if I want, I can bake my final terrain into Rhino and also internalize the data in this element. Bake, going to bake on my terrain 3D. Now if I come into Rhino, you can see the triangulation is much more uniform than we had previously. If we come here and change to a rendered view, we'll have a look at our finalized terrain. If I turn on my profiles in both directions, you'll see we'll have the terrain and sections of our terrain.